right? So I'm going to be solving this question from the documented question of chapter 27. And here it's clear that we need to know the difference between the magnetic field and like the flux, kind of like the difference in flux according to the position of the surface in which the magnetic field is going to, right? And here we have two different surfaces. We have this one, the ABCD, which is this one right here, which has an angle with the regular surface. And we also have this one right here. Okay. So we need to know what the flux is. And the flux is the amount of the magnetic field, or the amount of magnetic field lines that are going through a surface per unit area, right? So we can write the equation of the flux like this: B being the magnetic field, the area, and cosine of theta in this case being the angle between the normal line of the surface and the magnetic field. So using this equation, we know that the magnetic field was constant. So 0.8 is going to be the magnetic field. Now the area for the first one, I'm going to be working with the first one, ABCD first. The area is going to be this side right here, which is 5 meters, times 3.5, which is 17.5, and that is fine. Now we need to find the cosine of that angle, of this angle, because the normal line has an angle with the magnetic field right here, and those are going to be equal. Now we have a right triangle, so given that, we can find that the tangent of this angle is 4/3. Using that, we can find the angle, and it will be 53.13 degrees. So with that, we plug it in. I plugged it in as 53 just to approximate, and we get that the flux is 8.43. Okay, so first we need to determine the position. We need to find the angle between the normal line and the magnetic field. And this is going to be different for the next one, because now we have a surface like this one. And if we draw the normal line is going to look like this right here. And if we also draw the magnetic field right next to it, we get it like this. So the angle between those is actually 0. So the cosine of 0 is just 1. So I guess it would be easier to determine the flux, the magnetic flux going through that surface, through a surface that is which normal line is parallel to the magnetic field. So knowing that, we get the constant magnetic field. Now we find the area of this region right here. This right here is equal to this side, so it's 3.5, and this side, which is the height, you can say will be 4 meters. You multiply it, you get the whole area, which is 14 meters squared. You multiply the area times the constant magnetic field, and you get the flux. Right? Perfect.